The third of the revolutions that this section will deal with is the scientific revolution. And before we talk about the scientific revolution itself, we need to talk a little bit about the difference between science and technology. Now, there's many different ways to define science, but I need to give you a definition here then so you understand what I mean when I say science and also what I mean when I say technology. So technology is applying knowledge of how something works for some practical effect. You're understanding how things work. So for example, you know how to build a bridge, for instance, and you can apply that knowledge of how you build a bridge in order to build a bridge over a cliff, between two mountains, over a river, or something like that. Science explains nature through theories tested by experimentation and direct observation. That's understanding why things work. So to return to our bridge example, science would explain to us what the properties are of the materials you're using to make the bridge. For example, how much weight wood can handle versus how much weight steel can handle. Just how long of a bridge you can make before it collapses under its own weight through the physics of it. So you're understanding why that particular bridge can be built of that material for that length and so forth. Now you can have technology without science. You can build a bridge without understanding the physics behind how it works. You just know that through practical experience, right? So you don't need to necessarily understand just how much pressure wood can take before it breaks, how much pressure steel can take before it breaks, and the theoretical limits to how long you can build a steel or wooden bridge. You don't need to understand the physics behind that to actually build the bridge. So you can have technology without science. However, with science, you can develop more complex technology more quickly and efficiently, right? Simply, you cannot build a rocket or a car, an internal combustion engine, a tank, or a computer, or anything like that without understanding the scientific laws that govern it. And when I say build, I mean develop it, right? To come up to invent these kinds of things, right? You simply can't do it. Rocket ships, computers, tanks are simply too complex to just develop through trial and error. You need to understand physics. You need to understand calculus. You need to understand lots of different things to develop those complex forms of technology, right? So even though you can have technology without science, right? Remember, technology is basically understanding how things work, while science is understanding why things work. And you can have technology without science. With science, you can develop more complex technology more quickly and more efficiently. And to kind of give you a concrete example of this, East Asian and Islamic civilizations often understood technology quite well. For example, China developed gunpowder. However, Europeans will figure out and consistently apply the scientific method. And that's the difference between saying just developing gunpowder and learning about modern chemistry. China will indeed develop gunpowder, but that discovery in China did not lead to the development of modern chemistry, which of course with modern chemistry you can do things like make very efficient fertilizers and make bombs, right, that are more powerful than just gunpowder. You can invent dynamite, for example, once you understand modern chemistry, which gives you a lot more power than gunpowder. Europeans will do that because they will figure out how to consistently apply the scientific method of direct observation and experimentation. Right. So the key thing is that these other civilizations we've dealt with do often understand technology. They often make technological advances. Like I say, China is the country that develops gunpowder, not Europe. But Europeans will take these developments and develop a scientific method that will allow them to develop things like modern chemistry, which will give them immense power. And we'll especially see this in the next section when we look at the relationship between science and the Industrial Revolutions. Now, we're going back to this kind of complex issue of the relationship between religion and science, and I want us to understand and focus on this idea that it was complex. People often will take like an anti-religion view and try and oversimplify this and say, well, religion and science are just incompatible. Other people will take a really pro-religion view and will say, well, there are no problems. There are no tensions. And as a historian, my goal is to show that things are complex. So in understanding how and why the scientific revolution happened in Europe, we need to understand the development of medieval universities. First of all, just having universities is really cool, right? This kind of system of advanced education allows people to learn even more and to pass on the knowledge that people are learning to even more people. So universities are really cool. There were equivalents to universities in the Islamic civilizations and East Asian civilizations. So these aren't something that only existed in Europe. However, there's some special things about them in Europe. And I think it's kind of neat, by the way, to think that Lander University, like all universities, has its roots in the medieval period, right? Sometimes people look at the medieval period as like a time of ignorance. It wasn't. They didn't know as much as we know now because we've had time to learn more, essentially. But we have our roots in those universities, and they were religious by nature. The medieval universities were essentially built around religion. But the key thing we have to understand here was they were built around religion, and I want to stress we're dealing with Catholic Christianity, that saw rational inquiry as acceptable, right? Basically, the idea was God gave us minds, God gave us senses, and it is therefore okay to use that God-given reason, those God-given senses, to understand the universe that God made, right? As human beings, there was this belief that God created us and created the world around us, and it's not wrong for us to try and understand that world. And some medieval thinkers would go so far as to say God wrote two books. One book is the Bible, and the other book is the world that God created, right? We use our faith to understand the Bible. We use our rationality, in a sense, to understand the world that God made. And in this way, you had a religious view that was friendly to reason. We're not yet to science, but we have a religious view that is friendly to reason, that says that we can use our minds to understand how the world works, and in particular, that God governs the world in a rational way. Now, medieval universities also allowed a great deal of freedom. Scholars were able to share their ideas freely. They had to stay within the bounds of Catholic orthodoxy, but those boundaries were actually quite broad. There was actually a lot of different materials that you could discuss freely. And people look back at this time period and note the fact that Latin was like the educated language, and they would say, oh, this is terrible, all these people have to learn a foreign language in order to share ideas, and of course common people are kind of excluded from this. And I think this kind of misunderstands what Latin did, right? Latin was the language of the Catholic Church, and therefore was the language of education, because the church was, for many years, had basically been, or centuries, I should say, had been in charge of education. And the idea then was any educated person knew Latin. And what that meant was people in England, people in France, people in Germany, people in Poland, people in Northern Europe, people in Italy, people wherever who were educated knew Latin and could share those ideas. So Europe was united by a common language of Latin, at least among educated people. Right, so, peasants couldn't understand each other, but, French peasants weren't likely to meet English peasants anyway. But professors at universities did travel around and did talk to each other, and it didn't matter that this professor was from Poland, this professor was German, this professor was Spanish. It didn't matter because they would speak Latin to each other. And so this meant that among this university culture, there was a sharing of ideas. And one thing we have to stress is that scholars do not do work simply as individuals. They do them as communities. Scholars learn from each other and share their ideas. And Latin allowed for that sharing all throughout the continent. This only increased in the 15th century with the invention of the printing press. Now, I didn't have to physically go to Poland if I'm from England to share my ideas or to learn ideas. Those ideas could be written down and printed in books, which were relatively cheap. Before the printing press, for example, if you wanted to make a Bible, it could take like a year, and it would cost as much as a church. Like, I'm not kidding, like one single Bible could cost as much as a church, and it would take someone would have to spend like a whole year copying it out. But with the printing press, books became really, really cheap. So cheap you could actually buy a pocket Bible. And people of middling economic wealth were able to buy pocket Bibles eventually. So knowledge, in a sense, is becoming cheaper and easier to gain access to. So this leads to the formation of an international scholarly community in Europe. And we're not yet quite yet to science, but we are there to reason and logic, and you can't have science unless you accept reason. And there was this Christian understanding of the universe that said it was rational, that a rational God had made it, and we can better use our minds to understand, our reason to understand that God and what that God made. So when you put all these things together, you have a continental Europe religious culture that was fine, that encouraged the sharing of ideas, of reason, and so forth. Now, one good place to kind of start where we make this movement from just simple reason to science, and the difference is reason is just kind of like using your logic, using your mind to think about things, whereas science is connected to the idea of repeating experiments and direct observation, right? Like I said, we're understanding why things work, and we need to do experiments to do that. And I like to help us to kind of understand that by talking about this guy, Nicholas Copernicus, right? Nicholas Copernicus. And I say a scientific revolution ? And I'll get to why I say put the question mark there. But Copernicus believed that the Earth moved around the sun rather than the other way around. There is what's called a geocentric model, which holds the Earth as the center. Copernicus rejected that, and that was the common belief at the time based on Greek philosophy and a certain reading of the Bible. He rejected that in favor of heliocentric model, which says the sun is at the center. And that, of course, we know now is correct. Now, I say a scientific revolution ? Because in some ways his ideas weren't that revolutionary. Other people had these ideas before, and he was borrowing from their ideas because he was a university professor, had been trained at university, and actually worked and studied at multiple universities and was part of the scholarly network I just talked about. And he borrowed lots of ideas from lots of different people and put them together. So it's not so much like it was just like the single guy who launched a revolution because he suddenly understood something that other people didn't. Rather, he put the other people's ideas together with his own ideas in a way that many people found particularly persuasive. And I want to, again, stress that he doesn't do this alone. This is a group effort. Now, what we also have to stress, and this is where things, again, get complex, Copernicus was a priest. And this wasn't just an act. He was a man of faith. He really believed in God. But he didn't actually publish his book until he was about ready to die because he was afraid of what might happen to him. Right? This is around the time period where Galileo got in some trouble because of his ideas. So what's key here, I want to stress, just like in Islamic civilization, in Christian civilization, there were some forms of Christianity that thought science was fine, like that of Nicholas Copernicus. There were others who believed that science was a threat to religion because it seemed to contradict certain readings of the Bible. There are parts of the Bible that make it sound like if you read in a certain way, it makes it sound like the earth does not move, that the earth is the center. And some people looked at this and said, aha, science is challenging theology. It's bad. It's dangerous. We don't like it. So just like what we saw with Taqiyuddin in section 2, where there were certain Islamic understandings of their religion that were pro-science and there were certain understandings that were anti-science, we see the exact same thing in Christianity. What is key is that unlike in the Islamic civilization, the pro-science Christians win. Right? The pro-science Christians win. And it's very complex. I'm not going to go into too much detail. But even though there's this there are people who are anti-science, there are Christians certainly who are anti-science, they lose in the long run. The continental European system of universities, as well as the fact that their dominance, in a sense, will help lead to the pro-Christian scientists, pro-science Christians winning. Right, so we have to understand that. It's not that Christianity didn't have people who were opposed to science. There certainly were. And there certainly were Christians who wanted to stop science. But there were other Christians who thought science was great. And unlike in Islamic civilization in this time period, they win out. So scientific revolution then is free to develop based on these universities, religious universities that we've been talking about. And I think a perfect example of that is Isaac Newton. Isaac Newton lived in England, which among the European countries was probably one of the most open to science, right? Isaac Newton himself was a Christian, a kind of unorthodox one in particular ways, but he did identify as a Christian. He was a very religious person. He actually wrote more on religion, particularly the end of the world. He was fascinated by the idea of being able that he thought he had special knowledge that would help him to understand the book of Revelations and predict the end of the world. But while being a religious person, he was also very interested in science and lived in a place where he could pursue science. And he did a lot of things. He develops, for example, calculus, which is absolutely important for doing physics. I once took a course on calculus. It was very difficult, but calculus is like mind-blowingly awesome in ways that I am not mathematically inclined enough to explain, but it is awesome. But for our purposes, there are several key things that Newton represents. First of all, if you took physics in high school or taking it here at Lander, you know that physics teaches us the laws that govern the universe. And Newton started off applying his understanding of physics to how the planets move. But the laws of physics he develops, particularly his understanding of gravity, can also be applied to other things, such as developing accurate artillery. Right? You may remember doing physics problems in class where you are trying to predict where an artillery piece, if it fires, where its shell will land. Right? So Newton also kind of represents a bridge here. I had stressed earlier in this class, it may not seem like math and astronomy are that big of a deal in terms of giving you power, especially astronomy. It's like, well, how does knowing the planets, how they move, how does that help me? Well, understanding how the planets move leads to the development of physical laws that you can then use to develop accurate artillery. And being able to fire cannons accurately will give you power when you're fighting someone who doesn't know how to fire cannons accurately. So he represents this kind of practicality, right? In addition, Newton has an understanding of religion and science that go together. He sees God as a divine lawmaker. He argues that God, being perfect in a sense, developed perfect laws that govern the world without God necessarily intervening to do things, right? So this leads to this idea of laws, rational laws designed by a rational lawgiver, and we can use the reason that rational lawgiver, i.e. God, gave us to understand those laws. So Newton is doing some important things. He is not only showing that religion and science can go together, and that becomes kind of a dominant view, he is also showing us how science can be eminently practical, right? How it can lead to developing new forms of technology, like accurate artillery, that are really good. Also, Newton gives us also an example of a fundamentally optimistic view of the universe and the power of reason to bring unlimited progress. This rise of science, this rise to better understandings of the world, is going to make Europeans in many ways extraordinarily optimistic. And whereas people had traditionally looked in the past and said, well, things in the past were better, we had a golden age, now people are going to look increasingly to the future, saying, okay, how can we now that we understand this science, how can we now that we understand this technology, what kind of amazing things can we do with it? Right? So there's this kind of optimism that's going to develop.